Calculate the partial of w with respect to u and the partial of w with respect to v given the following functions. W equal to f of x comma y comma z is equal to numerator x plus 2y minus 4z with a denominator of 2x minus y plus 3z. X equal to x of u comma v, which is equal to e to the 2u end exponent, cosine parentheses 3v close parentheses. Y equal to y of u comma v equal to e to the 2u end exponent, sine open parentheses 3v close parentheses, and z equal to z of u comma v, which is e to the 2u. Right, based on our chain rule for three variables, we need to find partial derivatives of all of these functions with respect to each of their independent variables. So I'm going to show a little of my work, but not all of it. Some of this is scratch work. So w sub x, which is the partial of w with respect to x, I'll often say this as wx. Using our quotient rule, that is equal to a numerator of negative 5y plus 11z with a denominator of parentheses 2x minus y plus 3z close parentheses squared. Now, knowing the values of x, y, and z, they are functions, we see that this is going to be equal to a numerator of negative 5 sine, open parentheses, 3v, close parentheses, plus 11, and a denominator of e to the 2u, end exponent, open parentheses, 2 cosine, open parentheses, 3v, close parentheses, minus sine, open parentheses, 3v, close parentheses, plus 3, and that denominator is all squared there, or that portion of the denominator is squared. Now, I'll also note that as I was simplifying this, I did factor out an e to the 2u and reduce that. Okay, so just be aware of that. All right, next, we have wy, which, using our quotient rule, is equal to a numerator of 5x plus 2z over a denominator of parentheses 2x minus y plus 3z close parentheses squared. And again, making our substitutions, that will be equal to 5 cosine, a numerator of 5 cosine open parentheses 3v close parentheses plus 2 with a denominator of e to the 2u end exponent, open parentheses, 2 cosine, open parentheses, 3v, close parentheses, minus sine, open parentheses, 3v, close parentheses, plus 3, close parentheses, squared. Finally, wz, with our quotient rule, is equal to a numerator of negative 11x minus 2y, and a denominator of, open parentheses, 2x minus y plus 3z, close parentheses, squared. And that expression will be equal to a numerator of negative 11 cosine, open parentheses, 3v, close parentheses, minus 2 sine, open parentheses, 3v, close parentheses, and a denominator of e to the 2u, end exponent, open parentheses, 2 cosine, open parentheses, 3v, close parentheses, minus sine, open parentheses, 3v, close parentheses, plus 3, close parentheses, squared. Next, we want to find the partials of x with respect to u and v, y with respect to u and v, and z with respect to u and v. So we can apply our chain rule. So xu is equal to 2e to the 2u, end exponent, cosine, open parentheses, 3v, close parentheses. All right, and then x sub v is equal to negative 3e to the 2u, end exponent, sine, open parentheses, 3v, close parentheses. All right, yu equal to 2e to the 2u, end exponent, sine, open parentheses, 3v, close parentheses, yv will be equal to 3e to the 2u, end exponent, cosine, open parentheses, 3v, close parentheses. And then we have zu, which is equal to 2e to the 2u, end exponent, and zv, which is equal to 0. Now, for the chain rule itself, we know that w, partial of w with respect to u, is equal to wx multiplied by x u plus wy multiplied by yu plus wz multiplied by zu, and wv equals wx multiplied by xv plus wy multiplied by yv plus wz multiplied by zv. Now we have these expressions. We're actually finding a dot product in essence, as we've seen before, with these two functions, two sets of functions. All right, now if we combine functions or we look for like terms and things very carefully, we'll actually notice that we're going to have some terms simplify. That's what we want. All right, so wu is going to be equal to, in fact, they all have the same denominator, so we're going to go ahead and make this into one fraction. We're going to have a numerator of 2 cosine open parentheses 3v, open parentheses, negative 5 sine open parentheses 3v close parentheses plus 11 plus 2 sine open parentheses 3v open parentheses 5 cosine open parentheses 3v close parentheses plus 2 close parentheses plus 2 open parentheses negative 11 cosine open parentheses 3v close parentheses minus 2 sine open parentheses 3v close parentheses. Close parentheses. That is our numerator over our common denominator of open parentheses 2 cosine open parentheses 3v close parentheses minus sine open parentheses 3v close parentheses plus 3 close parentheses squared. Now, if you are to consider those terms, we have many terms that cancel out. In fact, all of this, so that wu is going to be equal to 0. Now, you'll follow a similar pattern to see that wv with some algebra is equal to a numerator of 15 minus 33 sine open parentheses 3v close parentheses plus 6 cosine open parentheses 3v close parentheses with a denominator of parentheses 2 cosine open parentheses 3v close parentheses minus sine, open parentheses, 3v, close parentheses, plus 3, close parentheses, squared. That is the derivative of partial of w with respect to u and partial of w with respect to v.